Good evening, guys. Just adding an extra lesson. This is as a reinforcement, okay, guys? There's no homework. I just want you to review it. I just want you to look at it because I'm revising few homeworks and I noticed it that you're making like some kind of careless mistakes. It's not bad at all. I appreciate your effort, but you actually making some mistake that I would like to address so you don't do it again. This is going to help the kids who actually haven't do the homework yet, but for the kids who already did it, most of you did very good. But it just just want to make sure like you get all the information that you can from me. So first of all, I added one extra lesson on I think completing the square. And now I'm going to do a reinforcement on quadratic formula and discriminant because a lot of kids or some kids are getting confused. Remember what I said when we started the lesson, okay? The discriminant is only the part that is inside the radical of the quadratic formula, okay? So I'm putting one next to each other. That's quadratic formula, that is discriminant. That means if there's somebody asks you to find the roots, the nature of the roots, so the only thing you have to use is the discriminant, which is this part right here. You don't have to do all this. I'm seeing few kids doing the whole thing to find the discriminant, and that's not what it is. I think maybe you're getting confused because on the lesson, the beginning, I gave you this as a do now. But the lesson in discriminant was only this part right here. So let me show you the two differences, right? Now, the quadratic formula, when they ask you to use the quadratic formula, is because you're gonna find the roots, not the nature of the roots, okay? So if I ask you guys, find the roots of this quadratic equation using the quadratic formula. So you gotta use that. Remember, you can always do factorization, okay? You can always do completing the square, but they being specific, use the quadratic formula. So the first thing you have to do is make sure you identify your values of A, B, and C. If you notice, I know I'm using the variable M here. I put X here, which is the same thing. Just think about that being the variable X. So what I'm doing is, this is my equation right here, my formula. So the negative that will remain, okay, that doesn't change. Now, because B is negative, remember, that goes in parentheses. Plus, minus, okay, radical B squared, which is negative, and every time it's negative, you have to put it in parentheses so you don't forget, minus 4 times 1, which is the value of A, times C, which is the value of, times negative 14, which is the value of C. Everything divided by 2 times 1. That's another mistake also that some of the kids are doing, because when X is not 1, you have to multiply by that number, and that's the example that I put on the bottom. So let's just do quadratic, right? Let's concentrate on this. So when you solve for that, you'll get positive 5 plus minus radical 25 plus 56, okay? Now, over 2 times 1, which is actually 2. I don't even know why I did that. But I did it in the second step right here. So when I did my second step, I simplified the radical, which is 25 plus 56 will give you 81 divided by 2, and 81 is a perfect square. Remember, this one right here will be the discriminant, okay? But remember, we don't worry about discriminant now. But just for you to know, the discriminant here will be 81 because it's a perfect square. It will be two rational roots, okay? Because 81 has the square root of 81 is 9, but that's going to be for the next topic right here. So remember, the discriminant here is, but let's not do that because I don't want you to get confused. We're just solving for the roots, okay? But then, let me just write it down here. This is the discriminant. But remember, I'm not looking for the discriminant in this problem. I'm solving for the roots, so I have to continue. So just, for knowledge, that will be 2 rational roots. But then again, this is not what I'm looking for. I'm looking for the roots. So what I do is, after that, I just separate my roots, all right? And I just write, oh, sorry about my phone. Just slide down a little bit. Let's just get back to put it back together. Okay, I think it's right there. Sorry about that, guys. So when I do that, okay, I'll get 5 plus minus 9 divided by 2. And after that, I separate my roots and I do 5 plus 9 divided by 2, which gives me 7. 5 minus 9 divided by 2 will give me negative 2 because 5 minus 9 is negative 4 divided by 2 is negative 2. So my root will be 2, okay? And if you notice that there's 2 rational roots because you have negative 7 and 7, okay? Now, before I go to that one, to the discriminant, okay, let me do that one discriminant now. Now let's go to the second problem on the right-hand side. Discriminant. Discriminant will ask you to describe the roots. So the only thing you have to do is concentrate on the inside part of the formula, which is b squared minus 4ac. So b here is negative 4, so you have to put it in parentheses, all right? Minus 4 times 1, which is the value of a, times 4, which is the value of c. And when you do that, you end up having 16 minus 16, which is 0. So when the discriminant is 0, okay? Discriminant is 0, therefore there's only one root, okay? Because remember, that's considered a double root. Therefore, the nature of the root will be one rational root, and it will touch the x-axis just once. Just one, okay? So remember, it's two big different things. Discriminant and quadratic formula. So let's do another quadratic formula when it's gonna be a little more, I won't say difficult, but it will get a little more work, okay? So here is, in this one, if you notice, the value of a here is 2, b is 8, and c is 3, okay? So if I do what I'm supposed to do, just substitute. This is what I mean, guys. Remember, because b here is positive, I don't have to put it in parentheses, okay? But if you do, it won't hurt. Everything, right, under the radical will be a squared, no parentheses because it's positive, minus 4 times 2 times 3. Okay, now remember, because a here is 2, you have to multiply the bottom 2 by 2. On the homework, some of the kids still multiplying times 1 when it's actually a different number other than 1. So be careful on that. Keep continue, all right, solving, and you'll get 64 minus 24 divided by 4 because 2 times 2 is 4. And if I continue with my process, I will get a plus minus radical 40 divided by 4. Remember, guys, I'm going to explain to you that later, okay? Because 40 can be simplified, remember, okay? If they don't ask you to simplify, that will be your answer right here, okay? If they ask you just what are the roots, those are correct. But most likely they're going to ask you to simplify. So radical 40, all right? If we simplify that, remember that radical 40, the larger perfect square that divides 40 is 4. So it should be 4 times 10. Now, the radical 4, the square root of 4 is 2, not radical 2. So now I simplify the 40, and that becomes this part right here. So instead of working with radical 40, I'm going to substitute that for 2 radical 10. So I bring down everything else, okay? Plus minus 2 radical 10 divided by 4. And in this situation, guys, also, we have to simplify this because you know that 2, 8, and 4, they're all divisible by 2. So you'll have to take asking to yourself, okay? Half of 8 is 4, half of 2 is 1, and half of 4 is 2. So that becomes minus 4 plus 1 radical 10. You do not have to write the 1, okay, over 2. So that, guys, will be your roots, okay, in simplest radical form. So this one right here is already in simple radical form. So now, if they're asking you, you know, because sometimes I like to do that, or even the state like to do that, they ask you to round to the nearest 100, tenth of a thousand. I've been using thousands, right? So if we round this to the nearest thousands, you have to split every root, okay? If, as you can see, I put my first root, which is x equals -4 plus radical 10 divided by 2. And if I put it on the calculator, I will get -0.419, okay? If I do my other root, I would write -4 minus radical 10 divided by 2, which gives me -3.581. So that will be the root as decimals. Remember, simplest radical form and decimal. Okay, so I hope that clarifies, what you have to do in the quadratic formula. So let's go back to the discriminant. Okay, the discriminant, we did already one. So I want to do another one, another two. Because also a lot of good from the homework are telling me when you have a negative discriminant that you have two irrational roots. That's not true, okay? Let's say if I find the discriminant of this one, I'm looking for the nature of the roots. So remember, I have my A, my B, and my C. So B here, because it's positive, I don't have to put in parentheses, -4 times -2 times -20. And when I multiply this, that will give me 9 minus 160. When I subtract 9 minus 160, I get -151. Automatically, when you have a negative discriminant, okay, that's the negative discriminant, you have imaginary roots, okay? You don't have irrational roots. You have imaginary. Just be careful, okay? That means that never touches the x-axis. Therefore, we have 0 x-intercept. Okay, so remember, every time you have a negative discriminant, okay, you don't have real roots. They are called imaginary roots. Therefore, never touch the x-axis. That means that is 0 x-intercept. Be careful, because on the homework, I see some of the students writing, it was -48, I think, on the homework, and they wrote down 2 irrational roots. And it touched the x-axis twice. And that's not true. Please be careful. And just one more, because this was the one that I was putting to you right here, I think number 2, okay? Because what I did is I picked that one just to show you the other example of the roots. A, B, C. If you're going to use this, right, you're going to plug it in the formula because B is positive. You don't need the parentheses, okay? Times A times C, you get 64 minus 24, which will give you 40. That was here from problem number 2 that I told you that I will explain to you later. Because not a perfect square okay, the nature of the roots are 2 irrational roots. Okay, so 40 is your discriminant. All right, therefore you have 2 irrational roots and you have 2 x-intercepts. Because remember, when we solve this problem, I'm sorry, it was right here. When we solve this problem, you see here the discriminant, which is the same thing, okay? So here I knew that with my discriminant, but I wasn't solving for the discriminant, I was solving for the roots. And at the end, you find that the roots were these 2 irrational numbers. You can see they were rounded, to the nearest thousand. But these 2 roots, if I don't round it, they are irrational because the number doesn't have an end. And that's what it comes to be, 2 irrational roots and 2 x-intercept. So now, guys, I hope this lesson will help you to understand better. And so far, I give you a reinforcement for all 3 lessons. As always, stay well, and okay, we'll see you soon. Bye. Have a nice weekend.